Hi, everyone. I'm Jeff Wagner, and this is the Open Force Field Infrastructure Update for Q4 2025 coming into Q1 2026. Some significant releases that we've made in the previous quarter have been Interchange 0.5 and Toolkit 0.18. The interchange release, the big change in it is that it avoids some ambiguity around which positions an interchange object actually uses when exporting or doing various other operations. One place where an interchange stores positions is this interchange.positions attribute. However, an interchange also owns a OpenFF topology object, and this is a copy of the topology as it was at the time of interchange creation. However, this topology, if you descend into it, has its own positions. It has molecules with conformers, and this would create some user confusion because these are not linked. So users would sometimes accidentally change the positions on the topology, and that wouldn't be reflected in the interchange dot positions. This has been fixed by restricting access to the positions attributes or other coordinate bearing things on the topology owned by an interchange. So this is I think, clearly positive development that avoids confusion, but it's a significant behavior change, and that's why we had the more significant version bump for interchange. Also, some coordinated changes in both interchange and the OpenFF toolkit have improved runtime for isomorphism comparison, which doesn't really matter to you, but this actually fixes some really bad performance issues that we were seeing with highly self-symmetric molecules or certain types of topologies with similar molecules repeated many times or other things. So if you had previously been having runtime issues with interchange creation or export to OpenMM and GROMACS and other things, go ahead and give it a shot now. With the changes in OpenFF 2.3.0 with NACL charges, you should expect to see significant runtime improvement there. And we've made a bunch of other changes, and you can check out the release notes for those. Now, most of our ecosystem has been updated to Python 3.14. Big thanks to Matt Thompson for leading that work. This excludes the QC and bespoke fit stacks. So because following on from our discussion at the last advisory board meeting, we're not planning to update bespoke fit for new Pydantic or new versions of Python. There is sort of a tangled web of interdependencies down below bespoke fit that would all need to be updated in a very coordinated manner, and we don't have the bandwidth for that. So this will continue to be usable, but it's just going to cap out at Python 3.12, which means you might need a separate Conda environment for that, but the files produced by BespokeFit, the OFF XMLs, can be used in other tools, no problem. The last quarter, we've also spent a lot of time collaborating with OpenFE. This was two major efforts, and one of them is working with OpenMM and OpenFE to update the OpenMM and OpenMM force fields packages to be able to handle Smirnov proteins and Smirnov molecules containing virtual sites. This is important because it does a lot of the proof of concept work and some of the implementation for adding support for these next generation force fields to OpenFE. So I know that a lot of you like Open Force Field because we can be used in open free energy calculations. And this will smooth your ability to use Smirnov force fields with virtual sites and with protein support when we release those in OpenFE. And this is going to be important as well because in our own force field development pipeline, even if you are not interested in running free energy calculations, we benchmark our force fields to ensure that they have good performance on free energy calculations before release, and this helps develop the infrastructure for that. We're also sharing maintenance of this tool called Pontibus. Pontibus is a not public-facing repository with some experimental workflows using OpenFE's tools, and this is critical for how we run benchmarks. So especially solvation free energies and relative binding free energies. These are things that we do, again, even just for small molecule force fields. This is part of our release process, and so it's important that we contribute back to maintaining this really useful tool that runs in OpenFE's ecosystem. We've also improved our handling of post-translational modifications. Since the last time I gave one of these updates, we've released Pablo 0.20 and 0.21. The documentation is greatly improved. So where using Pablo used to be sort of look at this example and try to make it work for your use case. Now it's we have a Pablo book. It's maybe a 20-minute read, but this goes kind of soup to nuts of PDB loading in the OpenFF ecosystem. You can see different options for different situations. And generally, I think Josh did a really good job with this, so I'd encourage you to read it. This is available just on the Pablo documentation page. There's a subsection now in the headers called the Pablo book. And importantly, this adds anonymous residue matching. So where our initial PTM prototype notebook, probably a third of it by length was matching up atom names between the template molecule that had the reference chemistry for your modified amino acid, getting all the residue and atom names in that to match to the same residue in the PDB. And that was manual and it was really ugly and it was a bunch of work. Josh has added support for anonymous residue matching, which means that it doesn't need to have the atom and the residue names match. It can just match by element and connectivity, supplied that your PDB meets some requirements like having connect records. So that's a big thing, and I think that was a barrier to adoption for a lot of people. And there's also several smaller bug fixes in Pablo version 0.2.1. So I encourage folks to give the PTM workflow another try if they had trouble before. And finally, we are preparing for our virtual workshop series for 2026. We had run a poll with the advisory board a few months ago, and we got really good feedback. We had proposed, I think, 10 topics, and we got them very clearly differentiated by preference. And looking at it, we realized that many of the topics could be merged, especially some of the high interest ones. And so the first workshop that we're going to run is going to be on post-translational modification handling and some general best practices in our ecosystem. And the second one is tentatively going to be fitting a Smirnov force field using SME. And again, these aren't just the specific topic, they're going to include whole adjacent topics that were highly voted as well. These are planned to be run in mid-March, so go ahead and watch your inboxes. We'll be sending out registration invites for these soon. And actually, sort of a feather in our cap, one of these instances of the probably the first workshop, the PTM handling workshop, will be hosted by Harvard's SB Grid webinar series. I think they had seen our previous work and invited us to give a talk. So the registration link for that one will look a little bit different, but hopefully this will be able to get our message out to more users. And in case you're not able to make any of the times, all the materials and the recordings for this will be made publicly available afterwards, so you can sit down with some coffee and go through them at your leisure and pause and customize things as you see fit. Thank you very much.